Forging of metal. Metallurgical plants all over the world are engaged in metal forging. This process makes it possible to achieve the desired shape and size using impact. A variety of non-ferrous and ferrous metals can be processed. Aluminium and its alloys, copper, titanium, and also iron are the most common. There are two types of forging, cold and hot. In this case, hot forging is shown. Heat is used to make the workpiece smooth and flexible. In each case, the heating temperature is different depending on the size of the metal part, the hardness, and the type of metal. During the first stage of processing, the workpiece is heated, and special furnaces are used for this. They can be combustion and continuous furnaces. Sometimes soaking pits and electrically heated furnaces are used. It should be noted that the piece must be heated gradually and uniformly. Only in this way can internal tension in the metal be avoided. The next stage of processing is called swaging. The workpiece is subjected to an impact, so the metal is compacted and the vacuum disappears. The processing equipment is called a hammer. This is a forging machine with a strike mass ranging from 1 kilogram to 5,000 or even more. The record is 300 tons. It should be noted that during the process there are inevitable mill scales, which fall off on their own or are knocked down with the help of the crowbar, and then cleaned up with a broom. That's why the metal is usually molded larger and heavier than necessary, assuming it will lose size in the forging process. Diamond mining. Here we can see the Diavik Diamond Quarry, located in Canada, 300 kilometers northeast of the city of Yellowknife. Every day, thousands of tons of stones are blown up in search of diamonds. After blasting, the excavator scatters stones that are more than 2.5 billion years old to reach the kimberlite pipe. This is the name of the geological body formed as a result of the ancient advance of magma through the Earth's crust, where the diamonds are found. The volcanic ore extracted from the pipe is loaded onto a 240-ton dump truck. Curiously, although the ore at this stage looks like a pile of common stones, each contains up to 700 carats of diamonds. In this condition, these stones are sent to production where processing begins. The first stage, crushing, is carried out with the help of special machines. Large stones are crushed to obtain smaller stones, but without damaging the diamonds. During this stage, the rocks become a mixture of small stones, some of them precious, but most of them are rubbish. In the last stage, the stones are divided into small lots and then submerged in hot chemical baths. After the bath, the rough diamonds are taken out. The creation of bells. Here we have the Royal Eichbout's Foundry, located in the Netherlands and built in 1872. It should be noted that since then, the technology of manufacturing bronze bells has not changed much. In the first stage, the master, depending on the size of the bell he wants to create, forms the external and internal molds. Then they come together. The internal mold is inserted into the external. The space formed between the molds is filled with molten bronze. As soon as the metal cools, the molds are removed and the bell is ready. Interestingly, the most difficult stage in the creation of the bell is the manufacturing of the molds. The material used is clay, which is applied layer by layer until it acquires the desired shape and size. The masters admit that the process is more complicated than it seems. If you over-tighten the clay, the mold will fall apart. If it's not tight enough, it also crumbles. When the mold of the dome is molded, it's covered with a layer of graphite. Then the mold is sprayed with sand, forming a new layer. It has exactly the same size as the future bell. When this layer is ready, it's covered with wax. The resulting structure is placed in the tank filled with sand with additives and left for a couple of days for contraction. After a few days, the tank is turned over and lifted. Inside, the sand forms an outline, which is then used to make the outer mold. The sand layer is removed from the inner mold as it's not needed. Now you can start creating the bell. The shapes are combined so that the space between them coincides perfectly with the shape of the future bell. The bronze is poured so hot that it takes 2 weeks to cool down, but the process doesn't end there. The almost finished bell goes to the last processing department, where it's polished in different places so that it finally has 5 notes. Creation of lava lamps. These decorative lamps are assembled in 2 parts. The upper part is made of glass and the lower part of plastic or metal. The construction of the glass part of the lava lamp starts at the factory, where hot air is blown into a container filled with hot glass. The air fills the mold so that the glass is distributed on the walls and takes the desired shape. Keep in mind that the glass part is something like a bottle. The machines in the workshop stand out for their extraordinary productivity, creating up to 6,000 bottles per hour. If the glass cools too fast, it will crack, so the bottles are placed on the conveyor and then move through a tunnel with strict temperature control, which gradually cools the material. At the same time, the aluminium bases and details for the lamps are made in another workshop. The metal sheets are cut into circles, then cold forged to the desired shape. In the meantime, the bottles begin to fill. The liquid, consisting of water, dye, and chemical oil, is poured into the interior. Wax is also put inside. The secret is that at room temperature, the wax sinks, as it's heavier than the oil, and floats to the surface. At the top of the lamp, the wax then cools, sinks, begins to heat up again, and so on, creating a cycle. To heat the wax, an incandescent lamp is used, which is placed in the base. Before the final assembly, the bottles filled with liquid and wax are placed in a hot bath so that the wax melts and becomes a liquid. Production of stressless chairs. The Norwegian company Ikornus ASA is creating special chairs that adapt to the position of the human body, providing maximum comfort. The secret of these chairs is their design features. The production process is not easy though, but the plant produces up to 1,250 chairs per day. In the first stage, a round, elastic and durable base is created. Trees known as European beeches are used for their manufacture. The layers of wood are dried so that there's no moisture in them, and then glued together. The rest of the work is then done by robots, as it's quite dangerous for humans. The glued layers of wood are treated with a press to give them a rounded shape. Then they're cut and folded to form a circle. Another robot joins the legs to this circle, and the resulting element is painted. In addition, to create the frame, metal and plastic are bent. Together, the wood base and metal skeleton begin to resemble a chair. The soft part consists of a dense foam layer, upholstered with a soft foam layer. A cowhide lining is placed over the resulting detail. Please note that each lining is hand-laid. The air is extracted from the foam to reduce its size and facilitate the installation of the lining.